Here are the answers to the homework questions on magnetism. The kinetic energy is equal to EV, where E is the charge. So rearrange that. Multiply both sides with a mass. Take the square root on both sides. And then you know that the radius is mv by qb. And substitute for mass times velocity. Those terms are all cancelled because they're the same. It's an electron, the mass and the charge are the same. They're going through the same magnetic field. And it's a ratio question, so that's why those terms are cancelled. So when you take R1 by R2, you get square root of velocity 1 by velocity 2. And that's obviously square root of 3. In question 2, you have to find the torque. Now remember that the magnetic field is given by 0.0951I plus 0.182J because it has an X component and a Y. And mu which is the magnetic moment is 0.315 K because it's along the z-axis. Now torque is I'm trying to explain that the magnetic moment is NIA. Actually it's NIA. So when you multiply the number of turns with the current and then the area, you get 0.315. That's why I got mu as 0.315. Now to take the cross product of mu and b, put ijk. Use matrices. I times 0 times 0 minus 0.315 times 0.182. All the other terms become 0, so you get 0.05733 I cap. And that's the answer. C is the answer. Question number 3. Clearly, on using the right-hand rule, the answer is out of the page. At first, the fingers point in the direction of the current. That is exactly as a positive charge moves. So that's I. And then you turn your fingers at right angles into the direction at which the magnetic field is. So obviously you turn it towards the left hand. Your thumb will be out of the page. And question 4, can use EV is equal to 1/2 mv squared or QV is equal to 1/2 mv squared. Make velocity the subject. So that will be square root of 2qv by the mass. Plug in the numbers and
Where do you get doors that you lock from the inside in there? Except when you get the people that are like, oh my god, I'm locking my car.
5,000 back. So that gives you 1224.74 meter per second, and then use it, plug it in the formula. R is equal to mv by qb to give 2 times 10 to the negative 6, so that is the mass. We got the velocity divided by charge times the magnetic field, and when you calculate it, you get the answer as 2.04 meter. Question 5, you have to find the orbital frequency time period is 2 pi r by velocity. That's circumference by velocity. So it'll be 2 pi mv by qb, because r is mv by qb. So the velocities get cancelled. And frequency is, of course, 1 over time period. So that's qb by 2 pi times the mass. So on plugging in the numbers, you get 1.6 times 10 to the negative 19 times the magnetic field strength divided by 2 times pi times the mass. Which gives 22.9 kilohertz. On number 6, just have to find the radius. The formula for radius is mv by qb, and it's going perpendicular, so just substitute the numbers. Mass, velocity, given, the charge of a proton is the same as that of the electron. And you get the answer as 0.2 meter. Number 7. The force is 0 because theta is 0 and sine 0 is 0. Remember, when a charged particle moves parallel to a magnetic field, there is no force acting on it. Question 8. The force is ILB. A simple case of substitution. Gives you 1 Tesla, and by the right hand rule, it's into the paper. In this question 9, you have to take the vertical component of the velocity to find the radius. So the velocity is at an angle of 25 degrees to the magnetic field. You resolve it into sine and cos components, and you only take the vertical component, which is v sine theta. Gives you 2.536 times 10 to the 5 meter per second, and then use that to calculate the radius. That's the mass of the electron. That's times the velocity divided by the charge multiplied by the magnetic field strength. And you get the answer as 2.4 times 10 to the negative 5 meter. On number 10, it only says the magnetic field is in a certain direction. It doesn't give you exactly, so there are 2 possible directions for the magnetic force on the charged particle. Moving on to question 11. Says half a revolution in 5 nanoseconds. So remember that for one complete, it would take 10 nanoseconds. That's the time period. And time period is 2 pi m by qb. Make B the subject. Mass of the electron given. Charge of the electron is there. And remember again that the time period is 10 nanoseconds, which is 10 times 10 to the negative 3 seconds. 10 times 10 to the negative 9, seconds. I'm just showing you that the time period is 10 nanoseconds. And when you calculate all that, you get 3.58 millitesla. So you would get 3.58 times 10 to the negative 3, which is 3.58 millitesla. In number 12, the initial velocity is given. So that's 1x plus 2y plus 3z times 10 to the 5, and the magnetic field is along the z-axis. So you only take the velocity perpendicular to the z-axis, which will be the components along the x and y. So you only take the components of the velocity that are at right angles to the magnetic field, because if it's parallel, no force acts. So you only take the coefficients of x and y, which is 1 and 2, square them up, add them to find the magnitude of the velocity. And then use that velocity in mv by qb. When you put in all the numbers, you get 4.655 times 10 to the negative 3 meter, which is approximately 4.7 millimeter. 13, again, electron is moving from east to west, so the current must be from west to east. Current is always opposite to the motion of the electron. So now use the right hand rule, fingers in the direction of the current, then turn the fingers at 90 degrees to show the magnetic field. That's obviously to the left again, and so the thumb is pointing up. Therefore the direction of the magnetic force is up. Because it's entering at an angle, the radius is not mv by qb, but mv sine theta by qb. And you have to find the theta, the angle. So just make sine theta the subject. So theta is 57.6 degrees. 15. That is the situation. Only half the coil is in the magnetic field, so the force acting on the sides are exactly opposite and cancel out. And the force acting on the top part is what balances the weight. Remember, there's no force on the lower part. So the force Bi times the length is equal to mg. And so B is mg by I times L. But m by L is given as 5.6. So it's 5.6 times 0.44 Tesla. Remember here that I multiplied by 0.6 because to find the total mass you would have to consider the whole thing. So that is 15 times 4 total perimeter of that square. Okay. And in 16, it's a QV cross B or QVB sine theta is the force. Theta is 90 degrees, so simple case of substituting the charge, the velocity and the magnetic field multiply. That gives 2.56 times 10 to the negative 14 Newton. In 17, see, since it's not a moving charge, there is no current and that doesn't produce a magnetic field. Therefore, it's not affected. You know, it's only when charges move that they give rise to a magnetic field. So, in this case, there is no magnetic field. And in 18, you define the force on a straight conductor kept in a magnetic field given by ILB sine theta. Theta is 90 because it's perpendicular. And therefore you get 50 newtons. 19. You know, the loop is flipped around. Excuse me. Flipped around by 180 degrees. So find the work done, which will be the change in potential energy, and work done is given by integral tau times d theta, and tau is the torque, which is NIAB sine theta d theta, and when you integrate that, you get cos theta, and 0 to 180 degrees, put in the numbers, cos 180 minus cos 0 and you get 0.040 joules. On 20, to find the magnetic force, it's Q V cross B, so velocity is along the x-axis and therefore it can be written as 30I well, the charge is 30 times 10 to the negative 6. Now velocity is 30I, B is 0.5 J plus 0.3 K. So use the matrices there. See, I times 0 times 0.30 and that is 0. J will give you 30 times 0.3, which is 9, and K will give you 30 times 0.5, which is 15. So you take the magnitude of the velocity by squaring 9, 15, adding them to the square root to get 17.49 meter per second. And then use Q V cross B. is 17.49 times Q, which gives you 5.25 times 10 to the negative 4. 121. Straightforward question. Force on a straight conductor carrying current is ILB sine theta. All quantities given here. I just make B the subject, substitute. I get 0.088 Tesla. 22. This is the same question that was done a few questions back, and same idea. It's same as question 15. In fact, just calculate mass by length from the same equations given there. You will get 5.6 gram per meter. 23. Cyclotron frequency is just frequency as done before. And 50% of the speed of light is 50 times 3 times 10 to the 8 by 100, so it's 1.5 times 10 to the 8. And velocity is QBR by the mass. Time period is 2 pi r by velocity, again circumference by velocity. Frequency is 1 over time period. So that's velocity by 2 pi r. And substitute for velocity from previous equation. I just forgot to write the mass there, so you got to put the mass. I hope you remember. And F is 1.6 times 10 to the negative 19. Magnetic field is 9 Tesla. 2 times pi. And there you go. The mass has to come there. So the mass is proton. Mass is 1.67 times 10 to the negative 27. Gives you 137 times 10 to the 6, which is 137 megahertz. The last question, because we need not do 25, so R is mV by QB, and RP by RA is just mV by QB. I flipped over the other side, cancel those terms. It's the same magnetic field. And then charge the alpha particle is twice the charge of the proton, because alpha particle has 2 protons and 2 neutrons. Its mass is about 4 times the mass of a proton. And plug in the quantities, cancel out. That's Vp by Va, and I get Vp by Va is equal to 2 times Rp by Ra, and Rp is equal to Ra, so it's the same radius. So I got 2, and I hope I have not made a mistake. And 25, as I mentioned, is not required. Thank you.